before we start, I just want to quickly introduce myself. I know we've gone through a fair bit of discussion earlier. So my name is Pan Yong. I run a startup here. It's called the Cyber Assembly. What we do is train people in cyber skills. So I do volunteer every now and then with CSA, bit of passion with young people, people with autism and cybersecurity and stuff like that. Yeah. So it's quite an honor to have a chat with you. You must be pretty late in California. What time is that? 12 a.m.
Oh, no. I'm actually currently in China, so it's.
Oh, right, that's fine. That's pretty safe. Okay, right.
Okay, thank
okay,
you.
Yeah, all right. Yeah. So I read since our profile has been it's quite amazing. I guess just to start the ball rolling is how's your interest in how do you start your interest in cybersecurity?
I see. Oh, that's a very good question.
Yeah.
So my undergraduate education was actually in physics. And then when I went to graduate school, I then decided to switch from physics to computer science.
Right.
And then there's a question what particular subjects within computer science that I would want to focus on. So given that I was studying actually theoretical physics, so it gives people who study theoretical physics a pretty strong theoretical background, but also one draw of computer science to me is its practical impact. So I wanted to work in an area which can have both a strong theoretical foundation as well as practical impact.
Right.
And also I always have a broad interest. So a field that actually is very interdisciplinary and so on will also be very exciting for me.
Right.
And more importantly, I think at the time, the internet actually was really just starting to become popular. And I could see that as the internet grows in its adoption and deployment and so on, cybersecurity is going to become an increasingly important problem, probably one of the most important problems.
Right.
And given all these considerations, and I think also studying security, it's just really fun. Right. You have to be really creative in that field, given also the attacker mindsets and so on. So yes, I decided then to focus in security. And it was, I think at the time, the security community was really still very small. It was very early. It was great to see.
So how long ago was that? How many years back was that?
So I started. I transferred into computer science in grad school in 1997.
Wow, that's so really early early in the days of Right.
Right. So it was, yes.
So it's really interesting where you almost move from theoretical physics to com science, which is quite, in a way same, but in a way quite different, right? Where one is much more applied, where one is where theoretical physics is. So do you find that challenging, having to move from maybe come up with equation of E equal mc squared versus writing a whole bunch of program, right? How do you find it? How do you find that kind of switch? Yeah.
Right. Yeah, that's a good question. Yeah. I think the switch was easy in the sense that actually, I think a lot of people who study physics in their undergraduates, later on they do move to other fields because physics does give you a really good training. And then oftentimes people who study physics are very versatile and they can move into other fields fairly easily. With that said, I think on one hand, it was very easy for me to switch from physics to computer science. On the other hand, I think there was some surprises that I didn't anticipate.
Right.
In the sense that maybe in retrospect, it should have been more obvious, but at the time, I certainly did not anticipate that. A little bit like actually what you just mentioned. So for physics, I think it's very much of a reductionist view, right? So that's one of the things that really drew me to physics early on, was that essentially, I actually clearly remember like one moment when I was studying physics in undergrad at Tsinghua. I was sitting in the library, and I often go to the library to study and so on. And then one day, I got so excited, I realized that's with just a few, like laws of physics, a few formulas, that we can essentially derive so much, and we can almost derive like the whole world.
Yeah, exactly.
So basically, the knowledge that you need to know in physics is actually very little, and then from that you can then derive so many other things, right? Whereas computer science is quite different, because in computer science a lot of it is artifacts that people have built. So in general, in computer science, the knowledge that you actually need to have in order to know how things work, actually it's much more. So you have to, if you want to know how a system works, you actually have to see how it has been designed, and then its implementation may not even meet the design, and that's where security problems can happen and all that. So you need to know more knowledge to know how things work. So
that's very interesting, right? It's almost saying that the law of the nature can be simply defined with formulas, but when human create stuff, we make it really, really complicated, right?
right, exactly. So in some sense, actually studying computer science is more work than studying physics, at least for me.
Exactly.
In that aspect.
Yeah, that's interesting. So would you recommend like students, and I also recognize that we have fabulous students in our audience joining for this session. Would you recommend students to say, look, as a strong foundation, go do physics, before doing computer science?
I see. In general, actually, I think if people can afford, I think it's always a good idea to build strong theoretical and mathematical foundations.
Right.
I think in general, it just helps you to have stronger mathematical skills, and also just, especially physics, I think it really helps you to develop a clear way of thinking. So a lot of actually, if you look at in the computer science field, a lot of the great computer scientists actually they studied physics during their undergrad, and some even had physics for their PhD and so on. And also, I think in Tsinghua at the time you cannot do double major. There is no such a thing as double major, but like in the US and in other countries, probably in Singapore as well, like you can do double majors. And I think oftentimes if you can do double major for computer science and like math or physics, I think that can be really nice.
Okay, cool. Yeah, so talking about a bit about, you mentioned a bit earlier about people who have lots of brilliant people with smart background in physics. You have pretty brilliant accolades as well. So you won the Test of Time Awards for 2 earlier papers, right? And those were done during your graduate days. Can you describe a bit more about your papers?
I see. Okay. Yeah. I guess so. You are talking about the Test of Time awards for my papers that were published in the IEEE Security and Privacy Symposium. I think this year I got 3 the Test of Time awards, and 2 of them were actually for work that I did in graduate school. Given the interest of time, I'll just give one example. So that's the paper on developing new techniques and methods for searching on encrypted data.
Right.
So again, that was really early. I think it was in the work was done in 1999 2000. So back then that was like way before like a cloud. Cloud computing and so on.
Encryption wasn't the big thing back then as well, right?
I think people understood that encryption could be useful, but certainly it's not as widely adopted as today. And at the time, I was working on a problem that now, looking at it now, it's really important, but at the time, it was certainly before its time. So the idea is you may want to store data on a remote server. So for example, in today's setting in the cloud. And for example, you may want to store your emails there. And you then, as a client side, you may want to download some emails, but you don't want to download everything. Sometimes you want to just do a search. For example, searching for an email, for example, in this case, containing the keywords like cybersecurity, innovation, a day or something. like that. And so, of course, if the emails are stored in plain text form on the server side, the server can just do an easy search and then return you the result.
Right.
But then in that case, you have to really trust the server to really write, because the server sees all the content of your emails, which are really sensitive. So the question is, can you do this better? Can you actually develop a new methods, essentially a new encryption methods, such that the email can be stored in an encrypted way, in an encrypted manner, so the server doesn't know the contents of your emails. But still, you want the encryption scheme is done essentially with this additional capability, such that the server can still do this keyword matching, so that when you want to do a keyword search, the server doesn't know, first of all, which keyword you are searching, and the server also doesn't know the content of your email. But however, the server can still do this matching so that the server knows which email contains your keywords, even though, again, the server doesn't know the actual content of your keywords or the email. And then the server can then just return you the relevant email, right? So the paper is essentially developing a very practical method that's very efficient, actually largely utilizes symmetric key encryption methods, right, to enable a new encryption approach to enable this. So,
but do you encrypt the entire document, or you encrypt parts of a document? So say
so
tokenize
that. Right. So you don't really do the traditional tokenization in the sense that in the traditional tokenization, you essentially tokenize the same words into the same token. Right. So then in this case, if in your emails, the same word appears multiple times, then they will all be tokenized into the same tokens. So then this actually leaks information about the content of the email. Even just from these kind of statistical analysis, one could actually, also learn information about the email and so on. So you need a more secure encryption methods that essentially will not have these type of issues, that it can provide like semantic security and these other types of stronger security guarantees.
Right.
So, but in this case, yes. So essentially the email is encrypted with like the word boundary and so on. For integer words. So this will allows you to search for separate words and so on. But however, the same words, even if it appears in the emails multiple times, they will not be encrypted into the same encrypted word, the same ciphertext, and hence provides stronger security guarantees than the traditional tokenization method.
Okay, so it's quite interesting. It's something I done 20 years back, 99. I can't remember. My math is terrible.
Right. It's like 20 years back, yeah.
Right. But it's really relevant today, right? Yeah, it's really relevant.
Exactly. That's why I think that's why a one Test of Time Awards is that the work was done like 20 years ago, but it's still relevant today, and it's even more relevant today. And there has been huge follow-up work in the space, just in general about secure computing in the cloud, how you can do this type of computation over encrypted data to provide different types of capabilities. So after this work, we also do work in, for example, enabling like range queries on encrypted data and other types of more sophisticated computation over encrypted data for the services.
Right. Yeah. So I think data privacy has become more and more a big thing. Everyone's starting to feel it much more personally, and I guess that also goes with how the trends of cybersecurity change, where you have found something and then or wrote a paper on something, and then 20 years down the road, we discover this extremely relevant. I guess from your perspective, being able to see a problem 20 years down the road, now 20 years later at this point, how do you see like the landscape of cybersecurity change, and where is it sort of heading to down the road?
Right. Yeah. That's a great question. I think also my research career in security also has essentially followed our very much is like it's an example of how the security field has evolved over time. So the security fields initially, you know, focused very much on like network security, how to defend against, like at the time there were like internet worms, how how attackers can attack the network and compromises machines and so on. And then it moved on to host-based security. How do you protect the host? How do you, in particular, increase the also software security on the system to protect the system from being attacked? And then we have then the web became popular. So web security was also very important. For example, we actually did a number of work. Some of them actually have been incorporated into the standards and in mainstream browsers about how to ensure that, for example, the browsers and also the web protocols are designed in a secure way, so that, again, to prevent web attacks. And then, of course, the mobile became popular. So there's also a lot of work in mobile security. We did a lot of work in that space as well. And one of my startups was also in the mobile security space that was then acquired by another security company. So then today, I think very much that's what my keynote focuses on. Is one part is the intersection between AI and security, and also data, data privacy and data security is really important. I call it, if you look at the evolution of the security field, earlier it was network-centric, network-centric security, how do you protect the network? And then it was host-centric security, how do you protect the host? And then, as I mentioned, there's web and mobile security. And now I would say very much we are in the era of data-centric security. So people now, I think, start to recognize it's not sufficient to just protect your network or your host. Really, the main asset you have, the main goal for all the security protection is your data. Exactly. And what the attackers want, of course, sometimes, they want to do denial of service attacks to bring down your service. But for the most part, how they actually, how their attack gain, impact or gain, give them financial gains and so on, it's often the data. So ultimately, the goal is to protect the security and privacy of the data. And hence, that's why I says right now, I think we are very much in the era of data-centric security. And I think this part will continue for a long time in the sense that really, like I said, data is the ultimate goal, is the key assets that we want to provide. So I think it's also good to see that the security field now focuses more on protecting the data itself. And this even goes to broader, concepts, even including like the non-technical side. For example, there are more and more like privacy regulations, like GDPR and CCPA. And a lot of this really, if you look at it, they really focus on data, focus on how to protect users' data privacy and all that. I think we are still at the beginning, but it's a really, really important problem, I think, for everyone.
Yeah. So I'm really interested on the point about AI and data and security. But before that, before I go into that, just one point you raised about so the non-technical part about cybersecurity. So I think it's really a general question. How important are non-technical skill for cybersecurity professional? Because we tend to image that cybersecurity professional, the guy with the hoodie, right? Stay in that room and then hack on. But I guess that many people will say, I won't get with you. And share your thoughts about how essentials are non-technical skills and how can people with different skill set contribute to the cybersecurity community.
Yeah, I think the non-technical aspect and also the non-technical part of the community is actually really, really important to the security field overall. And also, as I mentioned, that's part of the reason that I really enjoy security field as well, is because of its interdisciplinary nature. And given that security, on one hand, yes, we need to work on better technical solutions, but on the other hand, many problems, given that security is a really difficult and complex problem, we actually need these non-technical are another way to put it, and also not just computer science centric aspects as well. So for example, for security, a very important part is that security is it's never about perfect security. It's always, you need to do risk analysis, risk assessments, and so on. So the non-computer science part, for example, understands better the economics and how to assess risks. That's very important. And also, a big part of the system, it's not just computers, it's the humans, right?
Exactly,
like, often we say that the humans are the weakest link in the system. So then it actually, touches on psychology and to really understand how do you actually help users to be more effective in the system. And I think this part also going forward will become more and more important as we do a better and better job in protecting the security of the computer systems. Then as we have already seen, like more and more part of the attacks actually are coming from social engineering attacks, or just really focus on the human aspects, the weakest link in the system. And hence, we really need to figure out how to help humans, because unlike we can upgrade software, we can't easily upgrade the human brain and so on. So that also relates to how you essentially develop the system better, so that it's easier for humans to use, and also easier for humans to use it in a secure way. And also, so the legal frameworks, we talked about the CCP and GDPR, these regulations, and also there are other considerations. So also relates to incentives. So for example, people have talked about in the past, why software has so many bugs and vulnerabilities. Maybe there should be better incentives. For example, people who develop software, they should take more liability when the software has bugs and vulnerabilities and so on. This has been, of course, a long debate and so on. And it's not clear what the right answer is. But I think these are good examples of the right incentive models, and the right legal frameworks can really significantly change how the community in general, what they focus on, and how they prioritize and help the adoption of better technologies, right? So for example, a lot of technologies have been developed, including, for example, like the search on encrypted data type of approach that I mentioned, and many other technologies, but we don't see them being adopted and deployed in a timely fashion. Oftentimes, it takes decades for these technologies to be adopted. And if you look at the technical side, it's actually, again, like I said, some of these techniques and approaches are very practical. But I think the challenge is incentives. Why should companies and services adopt these better, more secure practices? If there's not sufficient incentives for them, then these more secure solutions and technologies won't be adopted, or won't be adopted in a timely fashion. I think so. These legal frameworks and so on can really significantly help with these.
It's really interesting, right, to think about an incentive model, right, for people to behave in a particular way. So that's really interesting. You mentioned a bit earlier about social engineering attack and stuff and that really triggers a thought that I always had around. If I look back a bit, say 2016, what happened in the election in the US, and how the Russian made use of disinformation and social engineering to sort of attack the human being. I'm not sure it's the best way to put it. And that sort of caught me thinking about, it seems that the mode or the attack vector have changed quite a fair bit. And it's starting to evolve, especially around things like AI and stuff like that. Maybe it's worth to share your thoughts about what the emerging cybersecurity attack in the space of AI, machine learning, IoT, and the likes.
That's a very good question. So in my keynote, I also talk about this issue. So today, for example, deep learning has made great advancements on many tasks and benchmarks. The deep learning training models have outperformed humans and so on. But however, we need to remember that still these deep learning models and in general today machine learning systems, they are actually very easily fooled. Attackers can develop various attacks, for example, by manipulating inputs to cause the learning system to give the wrong prediction or give the wrong answer. Or they can poison the training data set to cause the learning model to learn the wrong answer, and so on. So one example work that we did is to show that some of these attacks can even be effective in the physical world, where by putting some stickers on like a road sign, for example, a stop sign, humans can still recognize it correctly, but they can fool the computer vision system to recognize it as, for example, a speed limit sign and so on.
So that's a much easier way to hack an autonomous vehicle than trying to hack into the control unit, is that right?
Right. Exactly. I would say, the traditional, like the earlier security problems that we focus on are more on the, let's say, the systems level, whether the code has vulnerabilities and whether you didn't do the right access control and these type of issues. But with the AI machine learning, really the vulnerability and the security issues have moved one level higher. I call it the security issues of the learning system itself. It's the learning system itself that can be attacked. And this has huge consequences, especially as we deploy machine learning and AI systems more broadly. And we can imagine, 5 years, 10 years in the future, more and more of our daily life will essentially be controlled by some kind of autonomous AI learning systems. They will help us make so many more decisions and so on. So,
but that's happening now as well, right? Because every time I pop up Google is telling me what's the right answer. I'm not sure is that the right answer in the first place, right? My world of truth is decided by Google,
Right, but still, that's only just when you are using Google service, search or something. But what I'm talking about here is the power and the deployment of AI systems will become even broader, right? As you talk about smart like devices, IoT, and then more and more of the systems are actually being controlled by these learning systems. Then the security of these learning systems will become really paramountly important.
Right. So for, I guess
they are attacked, then they can really have severe consequences.
Right. So I guess there's two parts. You spoke quite a fair bit about vulnerability of AI, vulnerability of the data, the learning model. I guess from a blue and red perspective, right? How much AI is being used by the attackers in terms of the operation? I guess on the blue side of things, how much AI can be used to defend our networks and to make smarter decisions and give us better security in terms of the system we deploy.
Right. So in the security community, researchers and practitioners continue to push forward the various techniques and approaches to help develop better defenses, and some of those are powered by AI deep learning. So, for example, for malware detection and also for fuzzing, for vulnerability detection, we have all seen where deep learning has been shown to be effective. And also some of our own earlier work showed that deep learning can help with binary program analysis, help you to do similarity analysis to identify vulnerable programs and so on. So I think definitely the application of AI and deep learning in security I think it's a very exciting field. And we hope to see a lot more progress in the space. And in terms of attackers, I think attackers are always like motivated to right, to evade right, whatever defense that we come up with. And I think so. For example, like there has been I guess people have seen examples where, for example, for captchas, like a lot of these captchas, maybe you can use vision systems to solve them better and so on. And as a consequence, the captchas have become harder for people to solve. And sometimes you have these captchas that even become harder for humans to solve.
Right. Okay.
So I think, right, the expectation is that we do expect to see attackers will leverage more of these learning and AI capabilities in their attacks. Also.
So I just read the news 2 days back. Facebook formed a AI red team internally. So I thought that's quite an interesting concept. So in the world of COVID-19, it's worth to maybe share your thoughts about what's the impact of COVID-19 to cybersecurity, and what do you think are the opportunities and the challenges we are facing today? Yeah.
Okay. Yeah, that's a very good question. And again, so my talk will touch a little bit on this as well. And also actually, this week also, so I'm like co-organizing a summit called Responsible Data Summit.
Right.
And the first track is actually on responsible data in the time of pandemic. Right. So exactly actually focuses on this problem. I would say for in the time of COVID-19, the biggest issues we have in security and privacy is related to, again, as I mentioned, this data-centric security and privacy problem. To fight the pandemic effectively, data is super important. But however, a lot of this data is really sensitive. For example, we need data to do better contact tracing. We need better data to better develop diagnosis methods and drug development and so on. But today, in general, it's very difficult to for medical researchers and so on to get data. And also, even when they get data, there are still many questions about how you should handle the data privacy. And there are general questions about who should be allowed to collect what data and how long the data should be stored and how should the data be used and so on. So I think this data issue is really at the point of actually hindering the progress for addressing the pandemic. So we really hope that in the security domain, we can develop better security and privacy methods to enable responsible data use, so that on one hand, we can better extract insights and value out of data, for example, to help us better fight the pandemic, and on the other hand, to assure individual users that their privacy is well protected and so on.
So given it's a global problem, and I assume data sharing has to be global in nature, right? And how would like cross-border issue sovereign control of data, how do you sort of navigate or deal with those sets of challenges when it comes to data sharing?
Right, that's a very good question. And that's also what we are trying to help people understand in this responsible data use, is that oftentimes, so today, yes, still we are in the traditional paradigm where when you want to use data, you actually share the data, you share a copy of the data. But the challenge is that once you share a copy of the data, once the data has been copied out by someone, then there's no way for you to know what's going to happen to that copy of the data. You forever lose control of that data. So what we would like to enable in this responsible data use is that you actually enable controlled use of data. So that when someone wants to use the data, they don't necessarily get a copy of the data. They are able to compute the data in some way so that they can, for example, train a machine learning model or do some statistical analysis, but they never actually get a copy of the raw data. So that in this way, you can enable this control use. And I think this is going to be the solution, and it's going to be very popular, especially for this cross-border, data utilization and so on.
Right.
So for example, taking federated learning as an example, federated learning allows a group of participants to jointly train a machine learning model in a distributed manner, and they don't need to actually share their raw data to other participants. They just work together to train this distributed model, and they would share, for example, gradients during the training process. And even there, you can use a combination of crypto-based methods and also differential privacy and so on to really protect the whole training process from leaking sensitive information about individuals. And also the final model can be differentially private and so on. So this is another example, I think, why we need also a combination of technical and non-technical solutions, in the sense that in the technical field, we really see really exciting advancements in the area of security and privacy of data, this data-centric security and privacy technologies. We call them responsible data technologies, including secure computing, differential privacy, federated learning, and so on. And I think in 5-10 years, these technologies will really become much more widely adopted. But on the other hand, so today we have this GDPR, CCPA, these type of privacy regulations, but a lot of them still mostly focus on consent and so on. What we really need is actually regulations, legal frameworks that help encourage and support of the faster adoption of given the pandemic.
I can join.
But it's this week, and also all the talks and so on will be available on the website, and we have a amazing list of speakers. So I think it will be very beneficial and relevant to the audience of this event as well.
Right, cool. Yeah, I'd love to attend. In fact, I would love to have an option to sell my data. If that's like a free market opportunity for me to say, look, like Google, that's X bucks for my data. There you go, Facebook. That'd be a brilliant way to monetize my data.
Maybe then you'll be actually a great customer for our technology. So besides being a faculty at UC Berkeley, I'm also doing a startup called Oasis Labs that actually is trying to push forward on the on the technologies that I have mentioned and so on. And one part of that is to enable a responsible data economy, exactly to help individual users to gain, to maintain control of their data, but also at the same time to be able to gain more benefits from their data. So, like for example, in your case, you don't want to just sell your data, like your raw data, because then it can really have severe consequences on your data privacy. But with these responsible data technologies, we can actually enable data to be utilized in a privacy-preserving way, and also help users to maintain control of their data, and at the same time to enable users to gain more benefits from their data. So maybe you can join our beta program. We actually will be announcing the beta program very soon. That'll be great to have you.
I'll follow that. But I think maybe it's kind of interesting. You come to a very interesting point. I'm really interested because I'm an entrepreneur myself. So how do you come up with the idea of Oasis Labs in the first place?
That's a good question. I think in general, like I spend a lot of time developing new technologies in my research group and so on. But as the technology becomes essentially to a point where it could lead to real world impact, it's also can be a very satisfying experience to try to bring the technology into the real world to have more real world impact. And that's essentially the original motivation for doing Oasis Labs, is that, again, as I mentioned, with this really critical point, I would say, in history, where also in my talk, I talk a little bit about this as well, that we really have an urgent need to enable a framework for a responsible data economy and to build a future of responsible data. And in my research group, we have been developing various technologies in this domain, and it's great to see how we can bring the technology to the real world and help users to better maintain control of their data, and also at the same time to really enable data to be utilized in a responsible.
Okay. So if you were to so succinctly summarize the goal or mantra of Oasis Labs, what would that be?
I see. Right, we call it, we are building a platform for a responsible data economy.
Right.
So very much about building a platform to enable this controlled use of data, enable users to to maintain control of their data. Like one use case, for example, that we are in the process of launching is in the genomic use case, where so when we launch, it'll be the first time where we can enable users to actually be owners of their genomic data. To help them to maintain control of their genomic data. Their genomic data can be stored in an encrypted form, and the users can specify how they want their data to be utilized. So, for example, by utilizing secure computing technologies, using secure enclaves, and so on, we enable genomic analysis companies to run their analysis inside the secure execution environments, so that they never get a raw copy of users' data, but they can compute over the data if users agrees and gives consent and permission and so on. So this way, users can still benefit from their data, but at the same time, they maintain control of their data. So these are examples.
Okay, so that's interesting. Just one last question before we sort of wrap it up. I guess from taking the whole journey from doing research in universities, doing your own startup, and seeing how the whole landscape has changed in the cybersecurity world. I guess maybe you can share a bit about how what would be advice to the students, right, in the audience? They say, look, where if there's a way somewhere that's really exciting, interesting. I guess you have 10 different exciting, interesting things you want to do, but there's few interesting, exciting things you think you wish you have enough time to do, or you encourage the student to explore. What would that be?
I see.
Yeah.
I think one, I would really encourage the students to be brave to explore new areas, new domains. I think that's very much how my career has been. Oftentimes, I think I really enjoy working at the very forefront of the field. So the search on encrypted data example that we discussed earlier was just one example. As we discussed, that was like 20 years before the actual the adoption are when where it actually has become a huge field on its own. And there are many other examples. So almost every for every step in my research, if you look at it, is oftentimes we were the first to examine a problem, the first to ask certain questions and so on. And I think, especially for research, I think that's really a key part of research, and it's really, I think, one of the most fun part is that you really get to explore new territories, new areas that nobody else has explored before. I think I really strongly encourage the students to try to do that. And I think security is a great field for that, is because there are so many interesting aspects, so many interesting problems that in general, people just didn't have time to look at them, or didn't really think about them. But it's almost like if you turn a stone, turn every stone, there are really really amazing treasures underneath. I think you just need to be brave to go out there and try it.
Good. That's a great way to end it. Be brave and try new things, right? And flip stones. Right. Thanks very much for the time. And I wish you all the best, both for Oasis Lab and what we're doing responsible data. Yeah.
Yeah. Great.
Okay,
Yeah. Thank
cool.
you. Thanks a lot. Yeah, great talking with you.